Patience is a virtue. Why is this not working? There we go. Okay. So you're going to have the simplest ratio for these. So you would never see an ionic compound that you would have like K 4O2. You would never see a formula like that because that would not be in the simplest ratio. That does not apply to covalence. Okay, we're going to get into covalence later. But when we're talking about ionics, which remember is a metal and a non-metal, okay? When we're talking about a metal and a non-metal, it's always the simplest ratio. We call that a formula unit. That's, you don't need to remember that until you get into AP. So don't worry about that. But just realize that that's a simplest ratio. Okay. Again, you would never see this as Mg2Cl4. That would not happen. It would be simplest ratio. The overall charge of these has to be 0. And that's where that sheet that I just showed you, the chart that we're going to get into in just a minute, has that. Monoatomic ions, then, they only have 1 charge, except for some of the transition metals. The transition metals, then, they will tell you in parentheses which charge you're going to use. So they identify that as part of the name. You have to equal the number of electrons transferred, has to equal the number of electrons used. Those numbers, those charges, +2, -1, we call those oxidation numbers. And if you get into AP with me, I explain to you why we call them that. Right now, you just need to know that that's their name. So when I talk about a charge and I use the word oxidation number, they're the same thing. Good? All right. So again, those charges have to equal 0 by the time we're done. And the symbol then, when we write it, the cation comes first. That's your metal. The anion comes last. And we use subscripts to say how many of each ion we need. If we only need 1, we don't write a subscript. Good? All right. So let's flip over to that paper, your home, or not homework, your notes. Okay. So the first one on your notes, they give you an example. So you have an example, and then so that example on your notes is sodium sulfite. Now, anytime you see an ite, that should alert you to the fact that you're using one of those polyatomic ions. So if you get an ite or an 8, automatically flip that periodic table over because that's where you're going to need to get that from. Got it? All right. So our first one is sodium. That is Na. That is our metal. You're going to find that on your periodic table. It has a +1 charge. That's the only option for sodium. That's why they didn't give us a parentheses as part of the name. Okay. Then I'm going to figure out what sulfite is. Well, sulfate appears on my sheet. Sulfate is SO4 with a -2 charge. So sulfite should be what? To get to the ite version, what do we have to do? Subtract an oxygen. So this is going to be SO3. Everybody cool with that? Everybody see where we got all of these items? All right. Next thing you're going to do then is you're going to look for trying to see if this charge is balanced. So are we at 0? Plus 1 minus 2 would give me a -1. That is not 0. So what you have to do is you have to find the least common multiple between 1 and 2. What's the least common multiple between 1 and 2? 2. Least common multiple is 2. So I need both of these to be at 2's. So what would I multiply this by to get this to a 2? 2. So I need 2 of these. I'm going to need 2 sodiums. And how many of these am I going to need to get to a 2? I just need 1 of these. Okay. Then we put all of that together as the formula. So this is going to become Na2, and I only need 1 of these, so SO3. That is the formula then for sodium sulfite. Our next one says iron. It has a Roman numeral 2 in here, and it says phosphate. Okay, iron, I find on my periodic table, is Fe. I don't need to look up its charge. Why? Yeah, it told me right here what the charge of that is, because iron has 2 options. It's a +2 or a +3. So they have to tell me what option I need. And this one, they told me, is a +2. If they don't tell you what it is, it's a typo. Okay? There is a mistake there. Unless they're using a really old version of naming. And then they wouldn't call this iron. They call it ferrous, to be honest with you. Okay? So you'll know right away that they're using the old version. All right. So that is iron with a +2. Now, I need to find phosphate. What did I say if it ends in ate or ite? What do? Flip over your periodic table and find phosphate and fill in that formula here. Go. Okay, you should have found that that was PO4 with a -3 charge. Were you able to find that? Good. Now, are we at a 0 amount here? No. So we need to find the least common multiple between 2 and 3. What would that be? 6. So what do I have to multiply this by to get it up to 6? 3. And what do I have to multiply this by to get it up to 6? 2. So that means that I need 3 of these and 2 of these. See if you can write the formula over here for iron 3 phosphate using that information. Right? You should have written Fe3 because we needed 3 of them. And then this PO4, what do I have to do special to this if I need more than 1 of them? Yep, I have to put it in parentheses. So this is going to be PO4. And I'm going to put that in parentheses and write a 2 out here. All right, next one. Oops, that's not right. I don't have my mouse over here. Oh, it's right here. Good. Okay, it's life easier. All right, next one then is going to be copper 1. So copper, we've got 1, and that's going to be copper 1 chromate. So I've got my copper. It's a Cu. I know what my oxidation number is going to be. That's going to be a +1. They told me that right here. And then this ends in 8. So what do? Flip over my table and find chromate. Find it. So Cr04, and it has a -2 charge. So now I look and I see if we are at 0. Are we at 0? No, you're not at 0. I look for the least common multiple between 1 and 2. 2. So I need to get this up to a 2. How many of these do I need to get to a 2? 2. How many of these do I need to get to a 2? 1. I put it all together then and write my formula out. All right. The next one's ammonium. Now, ammonium is kind of a special guy. Ammonium is one of a couple polyatomic ions that are cations. So he's actually going to come from the back side of your periodic table. And this guy ends in 8. So it's also going to come from the back side of your periodic table. So see if you can find both of these, put them in your chart, and come up with the correct answer for this. That's right. All right, so ammonium sulfate, you should have had ammonium is NH4. It carries a +1 charge. Sulfate is SO4 with a -2 charge. So that means that I need 2 of these for every one of these. So when I go to write my formula, I have to put NH4 in parentheses because I need 2. And then my SO4 is not in parentheses because I only need 1 of those. How did you do on that? All right. Yes, me, sir.
Will we have to memorize the cations that are positive?
No, everything's on there. No, you always get that sheet to have on your test. You never have to memorize anything. There's no memorization in any of this. We'll use ammonium enough that you'll go, oh, that's right, that's a cation. And it's in the front here. I mean, you'll probably get used to that one. That's really about the only one that we use right now until like chapter 19. We use hydronium when we get to chapter 19, but that's way off. And it's usually not used as part of a compound. So yeah, don't worry about that one. The only one that you really need to kind of identify in your head and go, oh yeah, that's a cation. And like I said, it's going to come at the beginning of the word anyway. So, all right. Next one then is sodium fluoride. Now this one is a little different. Because notice that the ending here is no longer an 8 or an 8. So with the exception of a couple things like cyanide and hydroxide, all of the ides, these are the only two exceptions, all of the ides are going to come directly off the periodic table. So your nitride, for example, nitride would be nitrogen with a -3 charge. Phosphide would be phosphorus with a -3 charge. Your oxides would be oxygen with a -2 charge. Your sulfide would be sulfur with a -2 charge. So all of your ides, with the exception of these two, will come directly off your periodic table. Fluoride, chloride, you've heard of fluoride. They talk about getting fluoride for your teeth, okay? So that's coming from some sort of compound that had fluorine in it. The ide ending is indicating that those elements are now in some sort of compound. Cyanide and hydroxide then are your polyatomic ions. They're going to come off the backside of your periodic table. And that's CN -1 and OH -1. You got a question there, Dylan?
I'm just waiting to. I'm confused on how you do it. I don't see fluoride on that.
It's fluorine.
Oh, okay.
So Na is a +1. You're good with that, right? Sodium. Okay. Like I said, if it's an ide, for the most part, it's going to come off of the periodic table. So this is going to be fluorine. And then you'd have, like, below that would be chloride. You'd have bromide. You'd have acetonide. You'd have all of that stuff. Carbide. You have, you know, all of those come off the periodic table. So this is going to be fluorine with a -1. At this point, what is our overall charge? 0. So we just write down our formula. I don't have to do any math on that guy. It's kind of nice, huh? Sometimes you get those coming together like that. All right, so here's another one. This is chromium 3, and this is chloride. So where is this going to come from? Periodic table. So this is chlorine with a -1. I need to find the least common multiple between these, which is what? 3. So that means I'm already at 3 here, but I'm going to need 3 of these guys. So when I write this out, this becomes CrCl3. How you feeling about these? Good. This is the hypercritical day. This is a pivotal day in chemistry. You have to know how to write these formulas. You will sink in this class if you're not getting those. So I need you to call me over and talk to me. I'm begging you. I'm literally begging you right now to call me over if you're struggling with any of these. Okay? All right. Next one is nickel 2, and this is going to be sulfate. So this is my nickel. They told me that it's a 2 right here. This ends in 8. So I'm going to flip over my periodic table and find the formula for that. This is already at a 0 charge. So all we have to do is bring those together and write the formula out. I did not do that right. Let's try that again. There, better. All right. We have calcium hydroxide. Now, this is one of those 2 polyatomic ions that end in "ide" and kind of throw you a little bit for a loop. Okay? But you wouldn't think of an element on the periodic table being it doesn't flow, right? Like hydroxygen, like that's not right. Okay? So that should be kind of a clue to you that, like, this is not an element. So what is it? If it's not an element, what do? I'll flip it over, and we find that that's OH minus 1. So I'm going to need 2 of these for every one of these. So that becomes CaOH2. I need 2 of these. Every one of those. All right, ammonium chromate. Ammonium chromate. Ammonium, again, that's not one of your elements. That's on the back side of your periodic table. It's NH4 plus 1. Chromate ends in 8, so that should also be kind of an indicator that you flip that periodic table over and find that guy. These are not at 0. So if they're not at 0, find the least common multiple, which is 2. So that means that I'm going to need 2 of these for every one of these. And my formula for this then becomes NH4 with parentheses CrO4. Okay? So I'm going to have you work through the rest of those. I'm going to put up the answers to the bottom half of this on the board so that you can check your work as you're going through. I'm going to be walking around. I want you to call me over and get help for anything that you're struggling with. I then want you to do 7-3, okay? You've got a page in between there that's not 7-3. 7-3 is your homework. It is 24 problems. That is it. Okay? You are going to have a little bitty quiz at the beginning of tomorrow on these after we go through them. Little bitty, like 5-minute quiz. It's not going to be, it's just going to be 3 or 4 problems. It's not much. Okay? Because you've got to know how to do these problems. All right? And if you're struggling, what are you going to do? Come talk to me. Okay? I'm going to stop this recording real quick, and then I will help you. Okay, honey?